Alright, good afternoon. The last time we looked at exponential functions, we were looking at how exponential functions affect situations regarding population growth. In this regard, we're going to be looking at populations regarding squirrels. Now, one of the things we need to look at is what exactly is occurring to the population of squirrels after a certain number of years. I'm going to take some time now and just organize my work like we did before. So we're going to go ahead and do a table. And in our table, we're going to look at the years and the population of squirrels. Remember, it's very important to label your work so later on you can justify what it is that you're doing. So if we look at the population of squirrels, we know that at year 0, which is today, there would be 40 squirrels. But we also notice that within the course of 1 year, the population of squirrels will quadruple. That is to say, if we have 40 originally and it quadrupled, we would multiply 40 by 4, which in this case would give us 160 squirrels.
In 2 years, the squirrel population will be represented as 40 times 4. And this expression here represents the previous squirrel population, which was 40 times 4, which we consider to be 160. That squirrel population is again going to quadruple, which will give us a new squirrel population of 640 squirrels. Year 3, we will again express this squirrel population as 40 times 4 times 4 times 4. And recall that this expression represents the previous squirrel population of 40 times 4 times 4 quadrupling, which will give us a squirrel population of 2,560. At year 4, we will again represent this squirrel population as 40 times 4 times 4 times 4. And recall that when we are multiplying these numbers, we need to understand that the previous squirrel population was that of 40 times 4 times 4 times 4. And again multiplied by 4 to give us a squirrel population, in this case, of 40 times 4 to the 4th power. This allows us to simplify our expression of the squirrel population at year 4 in terms of an exponential expression. So our squirrel population will be 10,240 in 4 years. We can now create a simplified form of expressing the squirrel population by using exponents. And that is, we can have the squirrel population at year 2 be 40 times 4 squared. The squirrel population at year 3 be 40 times 4 cubed. And we can have the squirrel population at year 4 being represented as 40 times 4 to the 4th power, which will again give us a squirrel population of 10,240. As we begin to see again, what we notice is we see how the exponents are related to the number of years being expressed in our t-chart. That is to say, the years represented as year 1, 2, 3, and 4 show up in our expression of representing the squirrel population. Once we have this general rule or pattern that we begin to see in our table, we can now create a general rule or a formula that will allow us to determine a squirrel population at any given number of years. Let us write this formula to determine the squirrel population in 2 years, 4 years, or in this case, 6 years. Let t represent the number of years elapsed, and let us represent the squirrel population as 40 times 4, and this will be raised to the t power, which will represent the number of years elapsed. Now that we have this general formula, we can then use this formula to express this situation as an exponential equation. That is to say, our formula will be similar to that of y equals ab to the x. So in this case, the letter S will represent the squirrel population. The letter A will represent our initial squirrel population. The letter B will represent the fact that the squirrel population will quadruple every year, represented as the letter T. This equation, that is to say, this exponential equation, is going to represent the squirrel population after T years.